Okay, now statistics we will see, right? Okay, now we'll see statistics. Suppose we are recalling the last year knowledge, okay? Frequency distribution table. Okay, what is frequency distribution table? If you are given the items or else entries or data followed by commas with one another. Okay, suppose the heights of the students of a classroom, marks of a students of a class, next number of food calories of a students of class, like that ages of students, like that if you take in a data and you are making it as sorting the data, that is called cooking of data, which is called raw data to meaningful data. That is called the analysis of data. Okay, so data analysis is nothing but frequency, making the frequency distribution table. Suppose I have given like this 22, 21, 19, 18, 17, 15, 14, 13, 21, 22, 13, 15, 23, 21, 21, 12, 11, 19, 18, 17, 15, 14, 13, again 19, 18, 17, 11, 12, 13, 14, 15, 14, 15, 14, 14, 12, 11, 9, 10, 10, 11, 12, 11, 10, 10, 13. How many entries are there? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, and 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, and here 40. So there are 45 entries are there. Okay. So marks of an assignment for 25 marks of class of 45 students. Okay, so there are 45 students are there in a class. The assignment marks are there. Suppose marks in maths. Okay, for 25 marks. So number of students, number of entries 45 because every student has participated. What the highest? Highest is 23. The lowest is lowest is I think 10. So range of the data is equal to highest minus lowest. That is equal to 23 minus 10, which is equal to 30. So range of the data is 13 because highest minus the lowest. So this is like a data which is written in one by one, a sort without sorting. That's like a distributed, not distributed properly. Because like this raw data. This is called a raw data. Data which is not distributed, which is not cooked. This is not proper. This is not in a visible way. Just you are writing the data collected without sorting. Okay, data collected without sorting. This is called the raw data. Now, by seeing the data, I cannot come to an analysis. I cannot do. I cannot say what is the average, what is the highest, what is the lowest. I have to take time to analyze this data. Right or not? So it is taking time to analyze the data. This data is called a raw data, a data connected from the source. Now again, data is of two types. One is a primary data, and other one is the secondary data. So what is the difference of primary data and secondary data? Suppose I want to find the data, heights of the students. If I go to student and I have taken the measurement of the student and I collected directly from the source, that is called primary data. So data collected from the source, collected on hand from the source directly. Okay. Suppose in the case of secondary data, I want the date of birth of parent. I cannot go to parent, I cannot ask the student parent. So what I do, I collect from the office, like Gopal sir, I collect from the office, Prashant sir, I ask. I will get the data from the second source, which already data is available. I will take the data from that. That is called secondary data. Okay. So data collected from the source which already has. So already data is available. From that I collected the data. That is called the secondary data. Are you clear what is happening? So this is called the data collected from the source directly and data collected from the source directly and data collected from the resource. From the secondary source is already data is available with that, and from that I am collecting the data. That is called the secondary data. Note on this all. Now this is not a MIS connected data or within data. This has to be sorted. So this for this I will go for a frequency distribution table. Let us see it now. Okay. Note on this. Now note on this part. I will make a frequency distribution table. Then group frequency distribution table, continuous frequency distribution table, and discrete frequency distribution table. That all we will discuss. Then we will move to mean, median, and mode. 3 measures of central tendencies. That is the syllabus for this year. Okay. Note on. Okay, note it down. Okay, noted? Yes, noted? Right. Now, this data, I make already understood what is the range. H is equal to NH minus 2H. And number of metrics are 45 because their strength is 45. And these are the assignment marks in mathematics for 25 marks that I do. From this, I will find out the distribution of data. So, what is the frequency distribution table? Okay, frequency distribution table. So, by name it is understanding frequency distribution table. So, the number of entries are repeated, that is called the frequency, and each entry frequency is distributed, that is called the frequency distribution table. The data or the entries were sorted in an order to get the frequency, okay, as a table. It is called frequency distribution table. Okay, the entries are sorted in an order to get the frequency as a table. It is called the frequency distribution table. Right? So, what is the frequency distribution table? We are making this data into a table That is called the frequency distribution table, because the data is now dispersed or thrown, or else the data is like that, it was scattered. The data was not there to analyze, to identify, to make a note, nothing like that. So this is taken as frequency distribution table to have a clear analysis and to have an identity, to have a what you can say decisions makeover, and to have some changes adopted, some formations can be done, some decisions can be taken. We arrive at a lot of cooking or the formations from this data. We need to do the data distribution. That's why every entry is distributed with frequency in a tabulated and orderly form. This is called the frequency distribution table. Right? Now I'll make the data. So what I do is, the lowest is 10 and highest is 23. So I go with the entry frequency. How many times is coming? I take like this. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Up to here. So I go like this. Right? Now we go for tally marks. One time like this, second time 3 times, 4 times, and fifth one we take a bunch. That is called the tally marks. Okay? Before frequency we write tally marks, and then we write the frequency. So we take the frequency like this. Just should not count this. Now, first we start with each one. We go like this. 22, strike off. 22, you keep your 1. 1 time you keep. 21, 1 time. 19, 1 time. 18, 1 time. 17, 1 time. 15, 1 time. 14, 13, 1 time. 21, 22, 1 time. 20 repeated. Right? 13, 15. 13 is this one, 15 is repeated. Okay? Next, 23 1 time, 21, 12, 11, 21, 12, and 11. Right? 19, 18, 17. So 19, 18, 17. Next, 15, 14, 13. 15, 14, 13. Okay? Next, 19, 18, 17. Next, 19, 18, 17. 11, 12, 13. 11, 12, 13. 14, 15. 14, 15. So 14, 15. Again 14, 15. Again 14, 14. Now fifth one. 14, 1, 14. Understood now? So fifth one is taken as a bunch. And then again 14, 15. Are you clear? Like that is coming. Next. Okay. 12, 11. 12 is this one. And 11. Then 10, 10. 10, 10. Again 12, 11. Again 12, 11. Again 10, 10. Again 13, 14. 13 here, it came 14 and it came 1 time. Now see here, 16 not came anything 0 and 20 also not came. Now you take the frequency 4, 4, 4. This is 5 because bunch was there. This is 7 and this is here also 5. 0, 3, 3, 3, 0, 4, 2, 1. Now count all that 3, 7, 10, 13, 16, 21, 28, 33, 37, 41, 45. Total 45. This is called sigma Fi. Frequency total is equal to number of students. Now nothing is missing. Now it is already more order or not compared to the previous data. Is it more order or not? Compared to previous data, is it looking more ordered or not? Now see it. Is it looking more orderly or not? Which is better? This is distributed, but still it is also not grouped. This is one independent data. The data is collected independently. We can make still more grouped for this. Okay. So what I will do here, I will make a group distribution data. This is individual distribution data. Okay. Then I will make the group distribution table. So what I will do here, still I will make more concise and more meaningful, more understanding. So what I will do, this is group distribution table I will make here. Group distribution table. So what I will do here, so from the quarter 45, I divide 13. The number of classes will come. I will make classes. It is rounded around 3.6. Okay, 3.5. So I take here 4 classes. Okay, so total 4 classes I can take. Otherwise, I can go with it like that. I start with each 10 to 15, 16 to 20, 21 to 25, 26 to plus. This much enough. 10 to 10 to 14, 15 to 19, 20 to 24. Because there is no 25 also. I'll make 3 graphs also. Right? So this is called class. Whereas by 35 it is coming on 3 of 1, 3.1, so it is coming 3 classes. This is called class interval or class intervals. Up to 14, 10 to 14. These all will come out of this. 4 for 8 plus 4 plus 17 plus 7, 24. So total 24. And 15 to 19, 15 onwards. 1, 2, 5 plus 3, 8, 8 plus 3, 11, 11 plus 3, 14. Here also 14. And 20 to 24, 20 to 24, 24 not there. 4 plus 2 plus 6 plus 1, 7. So again sigma Fi 47. So this is called a group distribution. Now see here, this is very much clear for this data. Now you can see which is more effective, this one, or this one. Definitely this one. Because now you can see in the class 45 students are there. Students who are below average is 24 are there, and average are 14 are there, above average are 7 are there. So what is the percentage? 24 is around out of 45, 50%. Okay, half of that, 23, 50% around nearly, and 14 is 1/3, 33%, and this is 17%. Around, so this 50% is below average, so totally this class was below average class. Are you able to see it? Yes, this class was a below average class overall because it was showing that 50% of the students were low performance or virtual. Now, this data is not able to have decisions and analysis done. This data is very much clear, this part is okay, somewhat better. But than this is the more effective data. So, group of distribution table will be very much effective to have the analysis for the given data and then approach for any adoptions. Suppose then we can say this class is remedial class. Because 50% of students are below average. So what we do, we have to take extra classes, we have to teach less and practice, get them practicing more. We should not cover more part, but we have to make the part repeated. Whatever is taught, that has to be perfected for them. And we have to make worksheets for the average and below average students because they are together 50%. So we have to give worksheets for average and below average we have to make them practice, and above average we have to conduct tests for them because they are very less, they have to be able to be attained for their performance. So this way you need to have the analysis, and then for below average students again we have to make the individualized targets. The students who are below 10 to 14, they are almost mediocre, less than mediocre performances. So we need to take the attention of them and we have to be keen to their performance. So overall class, we can't expect the highest also more than 90 because highest score is 23 only out of what you can say out of 25, right? 90% is very less, and 60 to 90 very less are there. 60 to 40 more are there. Below 40 also more are there. So this way, what you can say, we need to go for the analysis of the given data. Now understood how to make the distribution table that is grouped. This is ungrouped. This is ungrouped distribution table. The data is not grouped. Here data is grouped, class wise. Distribution table. And this is group distribution table. Group frequency distribution table. This is ungrouped and this is grouped frequency distribution table. Are you clear? So, if a raw data was given, you need not leave this one as this way. We need to convert it into this way, group distribution table. So, you are given the data, how to find the highest and lowest, and then you have to make class size. This is 10 to 14. What is the difference? 10 to 14. 14 minus 10 is equal to including 10, 11, 12, 13, 14. So, there are 5. So, 5 units. So, class size is 14. Now, class mark is average of upper limit and lower limit. 10 plus 14 by 2. That is equal to 12. This is the class mark. Midpoint. Class mark is nothing but midpoint of class. So this is called, this the class size is 5. Class size is 5. Right? And class mark is midpoint of the class. Okay? Midpoint. So number of classes, how many are there? 3 are groups. Number of classes are 3 only up to there. Because suppose up to 50, you can take more classes. So there is a class-wise, group-wise distribution of the data, which is called the grouped frequency distribution table. Are you clear now? Understood how to make? You have to make tally marks understood, number of times it is coming, entry, then make the frequency. Every 4 hours you make a bunch, that is called the tablet from 5 marks as tally marks as 5. Then once you make the individual table, it's not clear, so you can construct it and then squash it to get an effective essence one, which is as into group or class-wise distribution table. This is called group distribution. Clear? Understood? And group distribution table is always useful to find the number of classes, class size, and class mark also. What is the lower limit and upper limit? The lower limit is this one. This is called the lower limit for 10, and upper limit is 10, 15, 14. This is called the lower limit and upper limit. Now, suppose 14.5 comes. We let it fall. It is not perfect. So what to do? This is discontinuous because there is a gap. Class are gaps now. After 14, 15 came. Again after 19, 20 came. 19.5 comes. Where you keep that one? So that's why the data should be, the classes should be continuous. We take that continuous frequency distribution table. This is called discrete. There is a break. Okay. So we'll make that discontinuous frequency distribution table into continuous. That also we'll see how to do. Note it up to here. Have you noted? Have you noted all of you? Okay, now so the upper limit of the previous class, they should have the correlation. There is a gap. So this is called discontinuous frequency distribution table. Now how to make continuous table to be made into continuous? How to do this one? We'll see here. Now see the gap 14 and 15. How much gap is there? 1. Divide by 2 that one. 1 by 2. So 1 by 2 you subtract from left side, add from right side. So what comes here? 15 minus 14 is equal to 1 divided by 2.5. Add to the left limit, subtract to the left limit. Subtract from the left limit and add it to the right hand. So what happens? 10 minus 0.5, 14 plus 0.5. Similarly, 15 minus 0.5, 19 plus 0.5. Then 20 minus 0.5, 24 plus 0.5. Now what comes here? The class. The class interval becomes frequency. Now this is 9.5 to 14.5 and 14.5 to 19.5. Again 19.5 to 24.5. And this distribution is only 24, 14 and 7. Now see here, this is a continuous frequency distribution table. Why? Because this is a continuous frequency distribution because see up to 14.5 here, 14.5 above here, 19.5 after here, 19.5 above, 19.51. That also you can keep here. So up to the upper limit and then next the next limit. Now there is no entry which are left out. Any number you can add in this entry. There is nothing left out in these entries in the distribution table. So always we have to see that the distribution table must be continuous, not discontinuous. Are you clear now? Are you clear? Now what is the class size? Now see the class size clearly. Class size, see here it is not clear. What is the class size? Class size is equal to upper limit minus lower limit. Now see here 14.5 minus 9.5. How much is it? What is class mark? Class mark or midpoint of class. Midpoint of class. That is equal to 14.5 plus 9.5 by 2. This is equal to 24 by 2. That is equal to 12. Earlier same class mark same class size. And what are the lower limits? Lower limits are 9.5, 14.5, 19.5. These are the lower limits. On the left side limits. Left side limits. What are the upper limits? So these are 14.5, 19.5 and 24.5. These are called right side limits. Here the right side limits. Are you clear? So lower limit, upper limit, class mark, class size, midpoint of the class, continuous distribution table, discrete distribution table, frequency distribution table. All of you are clear? What is distribution table? Okay, what is raw data, throughput data, right? All that is frequency distribution table. What is frequency? The number of times an entry is coming, that is called the frequency. So what is frequency? Number of times an entry is repeated in a class is this frequency. Or number of times, number of entries in a class. Follow. The number of times an entry is fallen in a class, it is called the frequency, denoted by F. Are you clear? So what you understood what is frequency distribution table? Now cumulative frequency we discuss, then bar diagram, then frequency polygon, and then frequency curve, that also we have to discuss. Then we will move to mean, median and mode. Note it down. Okay, noted? Yes? Okay, now. Next one is cumulative frequency distribution table. Cumulative frequency distribution table. Okay. So we have seen earlier 9.5 to 14.5, 14.5 to 19.5, 19.5 to 24.5, 24, 14 and 7. This is distribution table. Like that. This is the class and this is frequency. Now if I want to know up to 14.5, up to 19.5, up to 24.5. So up to 14.5, only 24 are there. But up to 19.5, it includes up to 14.5 and 14.5 to 95. So what comes here? Add 24 plus 14, which comes to be 38. Next, up to 24.5, previously up to 19.5 plus up to here. So 38 plus 7, that is called the 41. So this is called cumulative frequency. So we are counting totaling from top to down. 24, 24 plus 14, 14 plus 7. So this is called, we are counting from top. So this is called less than cumulative frequency. Less than cumulative frequency. Up to means less than, up to 14.5, up to 19.5, up to 24.5. This is called the less than cumulative frequency. Are you clear? So up to 14.5 is 14.5 and below. 19.5 up to is 19.5 and below. 24.5, 24.5 and below. Next, we are counting from top to down. So counted from top to down. From top to down. This is called less than cumulative frequency distribution table. Okay. Now from top to down, what is there here? This is less than cumulative frequency counted up to means below, up to 14.5 and below, 19.5 and below, 24.5 and below. Right? Next. If you take the counting from down to top, suppose class frequency above 9.5, above 14.5, above 24.5. Now you count from down. This is up to now, this is below. Okay? So above 24.5 up to means what comes here? 7, 7 plus 14. That is 21, 21 plus 24. That is 1. So all are above 24, 9.5 only. Okay, 45. This is 45. So this is called the counting from downwards. Down top. This is below. Up to means this is below. And this is above. So you are taking the lower limit this side and below you are taking the upper limit. So you are considering your upper limit because you will see highest from down. And you will see here above is take the lower limit. Now what comes counting from down to top? Okay? Greater than cumulative frequency distribution table. Because above means this is low, below means less than, this is greater than cumulative frequency distribution table. This is called the greater than cumulative distribution. So distribution table can be taken as cumulative, taking the total, that is called the less than or greater than. Less than means you count from top to down and you come below table. Greater than means count from down to top and reach above table. Noted? Are you clear with the distribution table now? Yes. Now again, suppose I want the data. Who are above? How many of the students are above 10? I'll get the 45. All of them are above 10. How many are above 40, 15, around 21? And how many are above 24? Highest score 7. Okay. Sorry, here 19.5. This is 19, fine. Above 19.5, 7 are there, above 14.5, 21 are there, above 9.5, 45 are there. Similarly, below 14.5, 24 are there, below 19.5, 13 are there, and below 24.5 are there. So highest is 24.5, nobody is there above, and the lowest is 9.5. Like that, we got the analysis. Are you clear? Understood? So like this, to analyze the given data and to do the lot of cooking and then communication and then analysis and then we go for necessary or needful applications on the given data, we go for the data analysis. So this is preparation of frequency distribution table is nothing but data analysis and data sorting. Okay. Now tomorrow we'll see about bar diagram, then frequency polygon, frequency curve, data, and then we'll go for mean, median, and mode. Tomorrow we'll continue. Okay. So thank you.